All right, let the fun continue. This is section 1-3, day number 2. We're going to finish up this section in this video, and we're going to pick up here with example 5, a distance problem. A plane is flying non-stop from Atlanta to Portland, a distance of about 2,700 miles, as shown in the figure below. After 1.5 hours in the air, the plane flies over Kansas City, a distance of 820 miles from Atlanta. Estimate the time it will take for the plane to fly all the way from Atlanta to Portland. So let's start, working on our picture here a little bit. Pictures really help. Here's Atlanta and Portland, and we know this entire distance is 2,700 miles. So I'll mark that in blue. After 1.5 hours in the air, the plane flies over Kansas City, a distance of 820 from Atlanta. So here's KC, and that distance from Atlanta is 820 miles, and that took us an hour and a half, 1.5 hours to fly that far. So they want us to estimate the time it's going to take to fly all the way from Atlanta to Portland. So looks like there's a couple ways we could approach this problem. We could start with the old DIRT formula, D equals R times T. Distance equals rate times time. And let's see, for this one, we want to find we're going to fly the entire distance. So the distance we're looking for is 2,700 miles. Estimate the time it takes to fly that far. So T is the variable we're solving for. So we need the rate. Did they give us the rate? Do they give us miles per hour anywhere in the problem? No, they didn't hand it to us on a silver platter, but they gave us enough information to find the rate. And that was in the data from going from Atlanta to Kansas City. We traveled 820 miles, and it took us 1.5 hours. So we could find the rate by saying, well, we know we traveled 820 miles in an hour and a half. So this is miles, and that is divided by hours. When we divide that, we will get miles per hour. So the 2,700 miles we're going to travel, if we divide that out, 820 divided by 1.5. Let me grab my calculator. So we want to do 820 divided by 1.5. And that turns out to, we got a repeating decimal here, but 546.66. 546.666 times time times t. So to solve for t, we're going to divide both sides by that 546.666 repeating. And a good way to do that on the calculator to get the most accurate answer is just to fill the display with sixes after your decimal point. So here we're going to do 2,700 divided by 546 and I'll just fill up the display with sixes to make this as accurate as possible, and hit enter, and we get 4.94. We'll round that off, that 0.39 to 4.94. T equals 4.94, and because we're talking time, we're measured in hours. Almost 5 hours to get there. Now that's one way to do it, and that's the way I believe that the book shows you in the book example. There is a different way, and in my opinion it's a better way. This is when I first looked at this problem, this is what got me. I like to think of it as a proportion. We're going to do it as, we could set it up either way. Let's do time over distance is equal to time over distance. So we know the overall distance we're looking to travel is the 2,700 miles, and we want to find the time it takes to do that. So the time would be x, the distance would be over 2,700, and that is equal to, we have this other smaller ratio. The time it took to fly from Atlanta to KC was 1.5 hours, and that distance traveled was 820. And once we have this set up as a proportion, we can cross multiply. Multiply here on this diagonal, you get 820 times x, and that is equal to 1.5 times 2,700. So 2,700 times 1.5 is 4,050. 4050, and if we take 4050 and divide that by 820, we get the same answer, 4.939, or round that off to 4.94. So when you look at this problem, it doesn't matter which method, jumps out at you, the way we did it the first time with time or distance equals rate times time, or setting it up as a proportion. Either way, we got the same correct answer. Example 6, an application involving similar triangles. This should ring a bell from geometry class when you first started working with similar triangles and proportional triangles. To determine the height of this building in Chicago, you measure the shadow cast by the building and find it to be 142 feet long. So here's the building we're looking for the height. That's x, our unknown. But we can measure the shadow of the building, and that shadow was 142 feet. Then you measure the shadow cast by a 4-foot tall post. So here's a post, it's 48 inches tall, and it had a shadow 6 inches long. Estimate the height of the building. So we're going to set up a proportion for sure on this one. We can do it as height is over shadow is equal to height over shadow. Now the one we're looking for, the height of the big building, that's our unknown x, and that shadow was 142 feet. And that's going to be equal to the height and the shadow of the post. And let's see here. Now you're probably going to think we need to get common units. And we don't necessarily have to in this one because, the height of the building we're looking for is in feet, and the shadow that is measured is also in feet. As long as, we're looking at this pole, the height of the pole is given in inches and the shadow is also given in inches. As long as we're consistent here, we have both inches, and as long as we're consistent here, we have feet for both of those. We don't have to convert these inches to feet. So we could just set up, height to shadow over height to shadow. So our height here is 48 inches over 6 inches. And if we cross multiply here, we get 6x is equal to this. So we divide this diagonal divided by 6, and we get x is 1,136 feet. Or we could convert this into feet. We could set up our first ratio the same. X over 142 is equal to the height of this pole is 48 inches. That is 4 feet. The length of the shadow was 6 inches. That's 1/2 a foot, or 0.5. And then we could cross multiply here. 0.5x equals 4 times 142. What would that be? 400 plus 160 plus 8, 568. And then you'd cross multiply and or divide by 0.5, and you would get the same answer. X equals 1,136 feet. Another way you could do it is convert this 142 feet to inches, and then you'd have the height and length of the pole shadow in inches, the length of this building shadow in inches. You'd find the height of the building also in inches. And then you could convert back to feet at the end. Mixture problem. These can get sometimes a little tricky. Problems that involve 2 or more ratings are called mixture problems. And they are not limited to mixtures of chemical solutions, as we're going to see in these next 2 examples. So you have invested a total of $10,000 in 2 different accounts. One account is 4.5%, the other account is 5.5%. And we don't know how much we put in each account. During 1 year, the 2 accounts earn the interest amount of $508.75. How much did you invest in each account? So first we come up with our verbal model. We have some interest in the 4.5% account, plus the other interest in the 5.5% account is going to equal the total interest. And let's assign some variable quantities. Let's say the amount we invested at the 4.5% is x. So x equals the money in the 4.5% account. So, how much money is in the other account? The money in the 5.5% account. How would we write that out? We have 10 grand total. We put X dollars into this account. How much is left for the 5.5% account? Well, if we have 10 grand total, and we already put X amount of dollars in the other account, the money left over for the 5.5% account has to be 10 grand minus whatever X is. Alrighty, let's start plugging this into our verbal model. And don't forget this 4.5%. That is going to be 0.045. And this 5.5% converted to a decimal is 0.05 would be the 5%, and the half would be another 5, 0.055. So, let's see what we have here. Interest in the 4.5% account. Well, that's going to be our percentage, 0.045, times X, the amount of money we put in it. So I'll underline that here in blue. That is our amount of money in the 4.5% account, 0.045 times X. Plus, we put the rest of the money in the 5.5% account. So that's going to be 0.055 times the quantity. Here's how much we put into that account, 10,000 minus X. 10 grand minus X. And that is equal to the total interest. And that was given in the setup of the problem, $508.75. 508.75. And now it's just solving for X. You know, for now, this 0.045X will not change. Plus, distribute the 0.055. So 0.055 times 10 grand is 550. And then we minus, distribute the 0.055 to the X. 0.055X equals our $508.75. 0.045X minus 0.055X takes us to negative 0.01X equals, and then we will subtract 550 from each side. We're going to subtract 550 here, subtract 550 here, and that's going to take us to negative $41.25. Okay, last step to solve for X, we divide by negative 0.01. So divide here by negative 0.01, that'll cancel. Divide here by negative 0.01. The negatives are going to cancel into a positive. And when we divide $41.25 by 0.01, we get $4,125. So are we done with the problem? Not exactly. It said how much did you invest in each account? Well, X was how much we put into the 4.5% account. So this is $425 in the 4.5% account. So then how much did we leave in the 5.5% account? Well, remember we invested 10 grand total. So 10,000 minus 4125 is 58.75. 58.75 in the 5.5% account. And you know those totals do add up to 10 grand. Alrighty. Another mixture problem, I think, in example 8. And this one is inventory. A store has $30,000 in inventory in single-disc DVD players and then in multi-disc DVD players. The profit margin on a single-disc player is 22%. The profit on a multi-disc player is 40%. The profit for the entire stock in the warehouse is 35%. So how much is invested in each type of DVD player? So here's our verbal model. If we take the profit from the single disc players, and then we add to that the profit from the multi-disc players, we get the total profit. So let's assign some variables. Let's call X our single disc players. Actually, that's not going to be the amount or the number of single disc players. We're talking, it says how much was invested of each type. So X is the dollar amount, the value of our dollar value of the single disc players. And remember, in the warehouse there was 30 grand total in inventory. So if X represents the single disc player's value, then 30 grand minus X is the remainder, which is the value of the multi-disc. So we've assigned our variables. X is single disk, 30,000 minus X are the multi-disks. And then we also bring into the profit. The single disk player is 22%, and the multi-disc is 40%. So, somewhere along the line, for the single disc, we're going to use 22% or 0.22. The multi-disc has 40%. Somewhere along the line, we're going to multiply that by 0.40. And the entire stock has a profit of 35. So, let's set up a little model here. Profit from the single disc players. Well, we have X dollars worth of them, and the profit margin is 0.22. So the profit from the single disc players is going to be 0.22x. Plus, switch over to red here, the profit from the multi-disc players. Well, they have a profit margin of 40%, 0.40, and the amount of those in the warehouse, dollar value, is 30 grand minus whatever X is. 30 grand minus X. And now here that's going to equal the total profit. Total profit. What is the total profit? Well, remember we got 30 grand in the warehouse, and the profit for the entire stock is 35%. So that's going to be 30 grand times 35%, 0.35. All right, let's start working our way through this. Step 1 is going to be to distribute that 0.40. So here we're going to have 0.22x plus 30 grand times 0.4 is $12,000. And we distribute the 0.40 to the minus x, so minus 0.40x equals. And then we multiply 30,000 times 0.35. That is $10,500. So on the left here, let's combine our x's. 0.22x and negative 0.40x comes out to a negative 0.18x. And then let's subtract 12 grand from this side. 10,005 minus 10 grand is negative 1,500. So we have negative 0.18x equals negative 1,500. Divide by negative 0.18. Oops. 0.18. Negative 0.18, and divide this side by negative 0.18, and we get X is approximately $8,333.33. 8333.33. Let me write that up here. X equals $8,333.33. So is that the end of the problem? No, it asked how much was invested in each type of DVD player. Well, remember, X was our single disc players. So we have $8,333 in single disc players. And then to find the multi-disc players, we subtract that from 30 grand. Remember, there's 30 grand total in the warehouse. 30 grand minus that would be our multi-disc. Multi is 30 grand minus that, or $21,666.67. And again, those are both going to add up to 30 grand. Okay, and I think we have one more example here. Using a formula. A cylindrical can has a volume of 200 cubic centimeters, centimeters to the third, and a radius of 4 centimeters, as shown in the figure. Find the height of the can. Well, a formula for a cylinder like this, if we think about the base of the can, that is a circle. So we're going to have pi r squared, and then times the height, pi r squared h. So volume equals pi r squared h. Usually in a problem like this, you're given the radius, you're given the height, you compute that all to find the volume. Now we are given the volume, and we're solving for one of the variables over here. So let's plug in what we know. The cylindrical can has a volume of 200 cubic centimeters, so volume is 200. That's equal to, we know pi is just a number, 3.14159, etc., etc. It has a radius of 4 centimeters. Radius was given, it's also there in the picture. So the radius is 4, and we're going to square that because it's squared in the formula. And they're asking us to find the height of the can. So h is the variable that we're solving for. So let's isolate h. First, we know 4 squared is 16. This is going to be 16 pi times our variable h that we're looking for. And let's divide both sides by 16 pi. So h equals 200 divided by 16 pi. And we can just punch that into the good old calculator, and we get h is approximately 3.98. 3.98. Make sure you're careful when you're punching this in the calculator. That's 200 divided by 16 times pi. Let's see how we'd punch that in there. 200 divided by 16 times 3.14. If you just punch it in straight across, you're going to get a bad answer. We got to make sure we group that 16 times pi. So you might want to do 16 times pi first and get 50.24. So we want to do 200 divided by 50.24. 200 divided by 50.24. There's our 3.98. You know, if you're using the fancier TI-89 calculators, you could do parentheses around that denominator. Oh, and we do have parentheses here. So let's try this with the parentheses. 200 divided by, and then we're going to group our denominator, parenthesis 16 times, and is there a pi key here? Yes, right there, 16 times pi. We close the parentheses. So if we look up here now, we have 200 divided by 16 times pi, and we hit equals. Boom, 3.98, rounded off. And I believe that's the last example. 2 problems for the team huddle. An inventory problem, so you're going to set that up as a mixture, and a shadow length problem. That's going to be a lot like, probably I think that was the second example. So pause the video, try those problems, and then fire it back up and see if you got them right. Okay, let's check out this first one. A nursery has 40 grand in inventory of dogwood trees and red maple. The profit on a dogwood is 25%. The profit on a red maple is 17%. The profit for the entire stock is 20%. So this is a lot like the DVD single disc and multi-disc in the warehouse type problem. How much was invested in each type of tree? So let's assign some variables. X is going to equal the dogwood tree. Dogwood. And we have 40 grand total. So if we do 40 grand minus X, the leftovers have to be the maple. And then we also have profit margin for each. The dogwood has a profit margin of 25%, or 0.25. The profit of a red maple is 17%, 0.17. And then we're going to have a total profit. The profit for the entire stock is 20%. Remember, we have 40 grand in inventory at 20% profit. And let's write that as a decimal. At 0.2 profit. So let's set up our equation. We're going to have 0.25 x that shows the profit. The profit margin is 25% on the number of inventory invested in the dogwood, 0.25x. And then we're going to add to that the profit from the maples, and the profit for the maples is 17% times the dollar value of the inventory of the maples, and that is the quantity, 40 grand minus x, and that's going to equal the total profit, and that's going to be this 40,000 times 0.2. 40,000 times 0.20. And let's see here, we'll distribute that 0.17. Here we have our 0.25x plus 0.17 times 40 grand is 6,800 minus, distribute the 0.17 to the x, 0.17x, and that's equal to 40,000 times 0.2 is 8 grand, 8,000. So here, collect our x's. 0.25x minus 0.17x is 0.08x. And then we subtract 6,800 from each side. 8 grand minus 6,800 is 1,200 bucks. And then we divide both sides by 0.08 to get our x. X equals $15,000 is invested in the dogwood trees. And we're not done with the problem. We need to know how much in red maple. Well, there's 40 grand total. 40 grand minus 15 grand is 25 grand. So $25,000 in the red maple. And there's our solution. And the second one is a shadow length. So a person who is 6 foot tall walks away from a 50-foot tower toward the tip of the tower's shadow. At a distance of 32 feet from the tower, the person's shadow begins to emerge beyond the tower's shadow. How much farther must the person walk to be completely out of the shadow? Ooh, this is a little different than the ones we've seen. So here we have a 50-foot tower. Here's our tower, and it's 50 feet. And this tower is casting a shadow. And we also have a person who is 6 foot tall. So let me come down here. And here's our person. And he has a shadow. And this person is 6 feet. So it says a person who is 6 feet tall is walking away from the tower. So there's the tower. He's walking away from it. He's walking across the tower shadow toward the tip of the tower shadow. Here's the tip of the shadow. This guy is walking toward it. And it says at a distance of 32 feet from the tower, the person's shadow begins to emerge beyond the tower shadow. So the guy's shadow here is in blue. The tower shadow is in black. He's walking along, and their shadows are overlapping. And right here, his shadow starts to emerge beyond the tower shadow. So that's where we're going to set our guy down here. And they did give us a crucial piece of information. Oops. They did give us the piece of information about how far he was. At a distance of 32 feet from the tower is where his shadow began to emerge. So this distance, he is now 32 feet from the base of the tower. How much farther must he walk to be completely out of the shadow? So here's what we're looking for. We need to walk that much farther to completely get out of there. So let's see, probably the easiest way to set this up would be similar triangles. So I'm sort of going to come down here. Here's our blue triangle. The guy's height was 6 feet, and this length was x. That's our smaller triangle. And what would be the big triangle? If this height is 50, and this comes down to the tip of its shadow, how long is this entire side here? Well, that's going to be 32 plus x. So we have another triangle, height of 50, and the base of this is x plus 32, or 32 plus x. We want to set up a ratio, a proportion, to solve for x. So we can get rid of this. And we could do it as height to shadow is equal to height to shadow. That's one way to do it. And here we'll do height is 6, shadow is x. So one of these would be 6 over x is equal to the height of the bigger triangle is 50. And the length of that shadow is the quantity, x plus 32. Another way we could have done it would be height to height is equal to shadow to shadow. So here, let's do left to right. This height is 6 to 50. So 6 over 50 is equal to x over x plus 32. Either of these is correct, because if you look, our next step is to cross multiply. Here we cross multiply the 50 and the x. Here we multiply the 50 and the x. On the other diagonal, 6 times the quantity x plus 32, 6 times the quantity x plus 32. It doesn't matter how you set this up as long as you are consistent in how you jump from triangle to triangle. And now we can just cross multiply and solve. I'll stick with this one here, our first one. Here we cross multiply, 50 times x is 50x, and that's equal to, don't forget we got to distribute here, 6 times the quantity, x plus 32. So we distribute the 6. 6 times x is 6x. 6 times 32 is 192. Plus 192. Let's get all our x's on the left, subtract 6x from both sides. That will be 44x equals 192, and divide by 44, and we get x is approximately, we got to round this off, approximately 4.36 feet. And I shouldn't have erased my original picture. Remember, we had this height was 50. We had our 6-foot tall person out here, and he had walked 32 feet from the base of the tower, causing the shadow. The question was, how much farther would he have to walk to get out of the shadow entirely? So that would just be another 4.36 feet. Alrighty, I think that wraps up section 1.3. The assignment, 1.3 day 2, pages 106 and 107. You're just doing these 5 problems, couple mixture problems, some other stuff in there. For 91, you're going to need a formula. It's like the can of cat food commercial, or the problem with the can of cat food. The formula that you're going to require for that problem is on page 102. Enjoy the homework.